CBW offers the only robot in the world which can remove parts from the mold faster than they can fall free by gravity. This means that for the first time, molders can purchase a robot which will remove parts from the mold without loss of cycle time. Customers are achieving productivity improvements of 10 to 30% as a result of faster cycles, reduced scrap, eliminated mold protection stoppages, and reduced labor costs. The particular system you're watching here is an 8-cavity, 12-ounce, straight-walled can molding system running at a 6-second cycle time. Scrap losses due to contaminated parts are completely eliminated because the parts are now removed to a clean area above the machine. Customer complaints are also eliminated. In this example, labor costs were reduced by 50% as a result of the system delivering oriented parts to the packaging station. Not only were these problems solved by the T190, but it did so while permitting an 8% reduction in overall cycle time. There are 4 key design aspects of the takeout mechanism. First, it operates independently of the transfer process. It is therefore designed strictly for speed. Secondly, space-age composites are used. It weighs less than 3 pounds and can therefore be accelerated at 26 Gs without harmful inertia effects. Third, a 6-horsepower servo motor is used, providing a takeout stroke of up to 48 inches in 150 milliseconds elapsed time. Fourth, high flow rather than high pressure vacuum is used, permitting parts verification in as little as 80 milliseconds. The parts are deposited into receivers using high-flow vacuum provided by a 1 1/2 horsepower centrifugal fan. A vacuum transducer verifies that all parts are present, and the robot is permitted to exit only then. The alternative, used by most other robots, is to use high-pressure vacuum and suction cups to grip the parts. This can mean up to a half-second delay to build vacuum and limits the permissible acceleration after parts capture. This segment shows the Slingshot handling a difficult-to-control part, which is a video box with integral lid and living hinge running in a 4-cavity hot runner mold. In this case, the user had 3 objectives. 1, cycle time reduction. When the parts are ejected by free fall, they tend to stick on the core and tumble as they fall. Extra stroke and clamp open time was needed to prevent closing on trapped parts. 2, labor cost reduction. A person was required to flex the hinge and close the lid. 3, quality improvement. Falling parts were marred by scuff marks, creating scrap losses or customer complaints. The installation of the Slingshot has reduced the cycle time by 2 seconds compared to free fall, improved the quality to what the customer calls the best we've ever made, and eliminated the labor costs completely. The parts are ejected into receivers which guarantee control during the 20G acceleration of the takeout arm. The effect of our high-flow vacuum can be seen, which actually pulls the parts off the ejector pins and into the receiver. Notice the sticking motion of the bottom of the box during ejection. Before the robot, this could have caused mold protection stoppages and occasionally mold damage. The Slingshot solved this problem. A digital transducer is used to monitor vacuum readings which verify that all parts are captured. The robot can then exit 80 milliseconds after part ejection. The swing arm, using suction cups, now transfers the parts at a more leisurely pace to the downstream equipment. As the suction cups contact the boxes, vacuum in the takeout system is momentarily cut off, and the parts release smoothly and gently to the swing arm. They are then fed by this conveyor in proper alignment for the flexing and closing system. A decline conveyor is used to bring the parts to floor level, where the subsequent automation equipment is located for easy accessibility for setup and maintenance. Finally, we secure the boxes in proper position, hold the lid back while the blade flexes the hinge, and then snap the lid closed. Closed boxes are swept laterally and escape in single file into the welding machine. Although this automation system represents a considerable financial investment, it pays back in less than 1 year in this case. It also ensures that this molder is producing parts of the highest possible quality in the most cost-effective and competitive manner. The system keeps the molder in the lead in the highly competitive field.